Welcome to M Health and Info, your ultimate source for all things health and wellness. Join us as we explore the latest in medical science, debunk health myths, and provide expert insights to empower you on your health and wellness journey. Hit subscribe, ring the bell, and let's explore the world of well-being together. This is M Health and Info, where knowledge meets vitality.
Digestion is the process through which the body breaks down food into smaller molecules that can be absorbed and utilized for energy, growth, and repair. It involves several organs and processes working together in a coordinated manner. Here's a detailed explanation of how digestion works in the human body. Ingestion. Chewing, mastication is a mechanical process that breaks down food into smaller particles, increasing its surface area for digestion. The tongue helps manipulate food within the mouth and mixes it with saliva to form a bolus. Saliva contains the enzyme amylase, which starts breaking down complex carbohydrates, starches, into simpler sugars, e.g. glucose, maltose. Mechanical digestion. Chewing by the teeth mechanically breaks down food into smaller pieces, aiding in the process of digestion. The tongue assists in moving food around the mouth and mixing it with saliva to form a bolus. Mechanical digestion increases the surface area of food particles, making them more accessible to digestive enzymes. Swallowing. Swallowing, deglutition, is a complex reflex involving the coordination of muscles in the mouth, throat, and esophagus. The tongue pushes the bolus toward the back of the mouth, triggering the swallowing reflex. The epiglottis covers the entrance to the trachea to prevent food from entering the airway, directing it into the esophagus. Peristalsis. Peristalsis is a series of coordinated muscle contractions that propel food through the esophagus and along the digestive tract. In the esophagus, peristalsis pushes the bolus toward the stomach. Peristalsis ensures that food moves in one direction, preventing backflow and facilitating efficient digestion. Stomach. The stomach is a muscular organ that stores and mixes food with gastric juices to form chyme. Gastric juices contain hydrochloric acid, HCl, and enzymes such as pepsinogen and gastric lipase. HCl creates an acidic environment, pH now 0.5-3.5, that activates pepsinogen, converting it into pepsin, an enzyme that digests proteins into peptides. Gastric lipase begins breaking down dietary fats into fatty acids and glycerol. Mechanical churning mixes food with gastric juices to form chyme, a semi-liquid mixture. Chemical digestion. Chemical digestion involves the breakdown of food into smaller molecules by digestive enzymes. In the stomach, pepsin breaks down proteins into peptides. Gastric lipase begins the digestion of fats. Chemical digestion continues in the small intestine with the action of pancreatic enzymes and bile. Small intestine. The small intestine is the primary site of digestion and absorption. The duodenum receives chyme from the stomach and mixes it with pancreatic enzymes and bile. Villi and microvilli on the intestinal wall increase the surface area for absorption. Nutrients, including carbohydrates, proteins, fats, vitamins, and minerals, are absorbed into the bloodstream or lymphatic system. Pancreatic enzymes. The pancreas secretes pancreatic juice containing enzymes such as pancreatic amylase for carbohydrate digestion, lipase for fat digestion, and proteases for protein digestion. Pancreatic enzymes are released into the duodenum to break down nutrients into absorbable molecules. Bile. Bile is produced by the liver and stored in the gallbladder. Bile contains bile salts that emulsify fats, breaking them down into smaller droplets to increase the efficiency of fat digestion by lipase. Bile is released into the duodenum to aid in fat digestion and absorption. Absorption. Absorption occurs primarily in the small intestine, where nutrients are absorbed across the intestinal epithelium into the bloodstream or lymphatic system. Villi and microvilli increase the surface area for absorption. Nutrients such as glucose, amino acids, fatty acids, vitamins, and minerals are transported into the bloodstream or lymphatic vessels for distribution to cells throughout the body. Large intestine, colon. The large intestine receives undigested food, water, and waste products from the small intestine. Water and electrolytes are absorbed, converting the remaining material into feces. Beneficial bacteria in the colon ferment undigested carbohydrates, producing gases and some vitamins, e.g. vitamin K. Feces are stored in the rectum until they are eliminated through the anus during defecation. Elimination. Defecation is the process of eliminating feces from the body through the anus. The rectum stores feces until they are expelled from the body during defecation, which is under voluntary control. In conclusion, the process of digestion in the human body is a meticulously orchestrated series of mechanical and chemical events that begin with the intake of food and culminate in the absorption of nutrients and elimination of waste. From the initial ingestion of food through the mouth to its final elimination as feces, each step plays a crucial role in breaking down complex molecules into simpler forms that can be absorbed and utilized by the body. Mechanical processes such as chewing and peristalsis work in tandem with the action of digestive enzymes and gastric juices to break down carbohydrates, proteins, and fats into their constituent components. The small intestine serves as the primary site for absorption, where nutrients are absorbed across the intestinal wall into the bloodstream or lymphatic system. The large intestine plays a vital role in reabsorbing water and electrolytes while fermenting undigested carbohydrates and producing certain vitamins. Ultimately, the digestive process ensures that the body receives the essential nutrients it needs for energy production, growth, and maintenance of overall health.